Now we will see the aspect of electronegativity, which is an important periodic property. So electronegativity is defined as the power of attraction of central electron pair towards a particular atom. Already in chemical bonding, what I have studied about this nature of HCl. HCl is covalent bond or ionic bond. The question arises. HCl is more covalent in gas phase and more ionic in aqueous phase, that is dissolved in water, that we have seen. So for the reason for this is that the relative electronegativity. HCl means hydrogen atomic number 1, it has 1 electron. Chlorine atomic number 17, 2 electron, 8 electron, outermost 7 electron. These two, 7 plus 1, 8, they form octet configuration. That is meant by HCl. So this link line stands for the common pair of electrons. So that both attain inert gas configuration or octet configuration. So here one electron pair is at the center between the hydrogen and chlorine nucleus. Hydrogen and chlorine nuclei, the line joining its center, line joining the nuclei and its center. This center position is the position of electron pair. As usual, cross denotes one atom's electron, dot denotes other atom's electron. Each shares. This is covalent bonding. Here, chlorine is more electronegative than hydrogen. So, means that it attracts central electron pair towards it. As per the definition, it attracts central electron pair means one from chlorine and one from hydrogen. So, attracts also hydrogen's electron. So, central electron, so hydrogen is less electronegative, chlorine is more electronegative. So, this electron pair moves towards chlorine. If the electron pair moves towards hydrogen's electron also moves towards chlorine. If hydrogen's moves, it is not transferred. In the case of sodium chloride, sodium's electron has been transferred to form sodium ion and chloride ion. Here hydrogen's electron moves towards, it is not transferred to chlorine. So the hydrogen becomes fractional positive charge, chlorine becomes fractional negative charge. So that is meant by electronegativity. Electronegativity is the power of attraction of central electron pair towards a particular atom. So electronegativity, it is a qualitative term. Unlike other two terms, standard questions would arise: ionization energy and electron affinity, or electron gain enthalpy, or energy terms. But electronegativity is not an energy term. It is called a power term. It is the power of attraction. What is the difference between energy and power? In physics you might have studied formula. The unit of power is watt. The unit of energy is joule. So watt and joule, they are connected by joule per second equal to watt, or energy by time is called power. Energy per unit time is called power. So in a fraction of time, the energy has to be dissipated. Whenever we think of government, we talk it as a powerful government. We don't call it as energetic government. Energetic government means which does useful things to the society. That is meant by energetic. That is different. Powerful means it is valid for 4 years or 5 years. Powerful government. Power, energy is available up to a period of 4 years or 5 years. Or once in 4 years elections come. Here also energy released in unit time. The same example we have seen, you remember. The car battery we use, it is called starting, lighting, ignition. It will give rise to different amounts of current. So during lighting, small amount of current is sufficient, 5 ampere or 10 ampere current is, but to start the engine, 5 ampere, 10 ampere current is not. You might have observed in general practice, drivers would switch off all other fans and lights before starting the engine, because during starting it triggers 400 amps. So in a fraction of second, momentary supply. 400 amps has to be supplied from the battery, then only it will start the engine. Otherwise, it will not start the engine. We have to push the vehicle or so in practice. So power means high rate, instantaneous release of energy. Instantaneous in a fraction of time. Here also chlorine is powerful to attract electron. So energy is required or energy is removed or energy is added. No question of energy addition or energy removal with the case of chlorine. Chlorine or fluorine. Fluorine is said to be most electronegative combo element. F minus is always stable. So there is no F plus. Halogens, Cl plus is there, ClO2, HCl. If we compare here H plus Cl minus. Oxygen minus means minus 4 plus 4. Cl plus 4 is possible. But there is no F2O. F2. If at all there is a compound, this compound is called OF2 and it is not written as F2O. If it is written as F2O, it is called fluorine oxide. Fluorine oxide means oxygen should gain electron. Fluorine will not allow anybody else to gain electron in its presence. As long as fluorine is there, electron should first go to fluorine. That's all. That is, so fluorine is the most electronegative. So electronegativity is the power of attraction of central electron pair. So it is a qualitative term, not like energy term, unlike your ionization energy or electron gain enthalpy. But because of its qualitative nature, there are two scientists who proposed the formulae for electronegativity. One is called Powerlynx rule of electronegativity. Another one is called Mulliken's rule of electronegativity. So Powerlynx rule of electronegativity, Powerlynx statement, he called XA minus XB equal to, he gives some qualitative result. XA minus XB equal to 0.208 into delta. Triangle stands for capital delta. So XA is the electronegativity of element A. So let us consider any covalent compound between A and B. If you consider any covalent compound between A and B, XA means power of attraction of A, that is electron pair towards it. XB is the power of attraction of B to attract the central electron pair towards it. So XA minus XB is given by point, he gives some empirical formula 208 delta. Here once again delta is defined as bond energy, the difference between the bond energy between A and B species minus geometric mean. What is meant by geometric? Arithmetic mean, sum of the data divided by number of data is called arithmetic mean. Geometric mean, product of the data raised to the nth root by the number of data. For example, if you have, let us recall, max, if you have three terms A, B, C, arithmetic means A plus B plus C by 3. But geometric mean means A into B into C whole cube root. That is called geometric. Here also geometric mean of EAA and EBB. Two terms are there. They are multiplication product followed by square root. This is called geometric mean. This is called delta. This delta has to be found. So this is the definition for Powerlynx scale of electronegativity. Powerlynx scale of electronegativity is given by XA minus XB equal to 0.208 delta. Delta in terms defined as EAB, that is bond energy between A and B, minus geometric mean of bond energies of homonuclear compounds EAA minus BB. You can illustrate with the example of HCl. So write HCl, XH minus XCl equal to 0.208 delta. Delta is defined as bond energy between hydrogen and chlorine minus bond energy of hydrogen molecule into bond energy of chlorine molecule, their square root is given by difference in electronegativity. So this is the Powerlynx scale of electronegativity. It somewhat complicates. The rigorous calculations are to be made. All other parameters has to be noted in the case of Powerlynx scale. One another scale of electronegativity is called Mulliken's scale. He made the process quite simple. He viewed electronegativity is the combination of ionization energy and electron gain enthalpy. Ionization energy is the energy requirement process. Electron gain enthalpy is the energy releasing process. So, he defined Mulliken's electronegativity Xm. Xp is Powerlynx electronegativity. Xm, it is not metal or phosphorus. It is named after the scientists. So, Xm is Mulliken's electronegativity is nothing but average of ionization energy and electron affinity or electron gain enthalpy. Whereas Powerlynx electronegativity is as usual defined as Xa minus Xb equal to 0.208 delta, delta being defined as the difference between EAB minus geometric mean of EAA and EBB. So, for any system, Powerlynx electronegativity and Mulliken's electronegativity, how they are related. Mulliken's electronegativity for any given system is greater than roughly 3 times of Powerlynx electronegativity. So, Mulliken's electronegativity is greater than 3 times that of Powerlynx electronegativity. These are only rigorous sums. Lastly, to revise, we have seen about the effect of now how the electronegativity varies. Electronegativity decreases along the group and increases along the period. Increases along the period because along the period more positive charge. Systems are more positive charge. More electronegativity capacity to attract the electron pair. Which species will attract the electron pair? If it is more positive charge, it will attract negative. Electrons are negatively charged. So, electronegativity increases from left to right. It has a maximum electronegativity of halogens. So, next to halogens, then your helium, neon, argon, krypton, xenon, radon. These are most electronegative. They are called noble gases. You cannot add electron, you cannot remove electron in these systems. In a critical case, they can share only the electrons. Krypton fluoride, xenon fluoride, they can share. That is to be noted. So, electronegativity is increasing from left to right, or in other words, first 2 group elements are called electropositive elements. Halogens and oxygen group elements. Oxygen, sulfur, selenium, tellurium, halogen, fluorine, chlorine, bromine, iodine. All these they form the hydrogen compounds. HF, HCl, HBr, HI are the hydrogen halides. H2O, water, hydrogen sulfide, hydrogen selenide and hydrogen telluride. So, they can form. Here these are ion because oxygen is more electronegative. It is even can be less electronegative than fluorine, but it is more electronegative than other elements. That is to be noted. So, electronegativity increases from left to right. It is maximum for halogens. Here the inert gases are not compared. That is why it is told that it is maximum for halogens. Electronegativity is least for first group and second group elements. So, that is why they are called electropositive elements. Electropositive. So, electropositive elements, electropositive character, capacity to donate electrons. Electronegativity, capacity to attract, it is not accept. So, there are slight differing terms, you have to be careful. Accepting the electron, it can be in the form of sharing. Attracting the electron, it totally removes. So, that is why hydrogen fluoride. Fluorine is the most electronegative. So, it will not form its positive charge. Never. It will not form its positive charge at all. That is to be noted. Now, lastly, what is the significance of this ionization energy, electron affinity and or electron gain enthalpy and electronegativity. So these are important. First two terms are important in ionic bonding, whereas electronegativity is important in covalent bonding. So in the case of covalent bonding, you have seen that polarity of a covalent bond. Ionic compound, polar compound. Polar means partial charge characteristics. Polarity of a compound, partial charge characteristics. So partial charge characteristics are influenced by electronegativity. Whereas already we have seen that low ionization energy for cation and high ionization energy for high electron gain enthalpy or electron affinity for anion. So fluorine, halogens and oxygen group in oxide, sulfide, selenide, telluride. They form preferably their second anionic charge. Halide, fluoride, chloride, bromide, they form unit positive charge. So that is to be noted. Even in the case of molecular species, carbonate, sulfate, their charges are to be noted with respect to the. So electron gain enthalpy is important in anion formation. Ionization energy is important in cation formation. That is why even some oxides are ionic. Magnesium oxide is ionic, means that Mg2 plus O2 minus. Magnesium can lose 2 electrons, oxygen can gain 2 electrons, so it readily forms ionic compound conveniently. There is a formation of ionic, but carbon and oxygen, they form covalent compound. So it depends upon the environment. Oxygen simply equally powerful oxygen, so it forms covalent bond. In the presence of magnesium, magnesium has a tendency to lose electron, it has a tendency to gain electron, so there is a transfer of electrons between magnesium and oxygen, it forms magnesium oxide. This is an ionic compound. But carbon also want of electron, carbon cannot lose electron, 4 electron, or carbon cannot gain 4 electron for inert gas configuration. So that is why it wants to share. So it is wanted, both of them wanting electrons means they are sharing. So the same element, whether it gives rise to ionic or covalent bond, is influenced by ionization energy. So already we have seen about this question. So ionic compound formation favorable considerations are cation forming element, its ionization energy should be low. Anion forming element, its electron affinity should be high. And covalent bond, polarity of covalent bond arises due to the difference in electronegativity. If there is no difference in electronegativity, compounds are non-polar. Benzene is a non-polar solvent. Water is a polar solvent. So benzene formula C6H6. Water H2O. So only 3 atoms are there, but it is highly polar. Here 12 atoms are there, it is non-polar, because carbon, all carbon, there are 6 carbons, structure of benzene is alternate double bonds, CH, 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 like this. Alternate double bonds means there is a better interaction between the carbon atoms. So better interaction, it can, already carbon is in strong bonding with adjacent carbon atoms, so it cannot afford to attract hydrogen's electron. Even though it is more electronegative, it cannot afford to, already it is in tight packed with the adjacent systems. So that is why it is non-polar. So polarity of a covalent bond is influenced by relative electronegativity. Lastly, the significance of electronegativity and also some more properties. Because of more electronegative nature or less electronegative nature, the compounds would be forming, different types of compounds are formed. That is to be noted. But next is the variation with the metallic character and valency and nature of oxides. Acidic nature of oxides. how they are compared in terms of electronegativity. How they are compared in terms of electronegativity, that we will see. Now, lastly, we will see the implication of electronegativity of any element on these properties, namely valency, the nature of oxides. Oxides are divided into four types: acidic oxides, basic oxides, neutral oxides, amphoteric oxides. And the reactivity of elements, how it is related to electronegativity. These aspects are to be noted. Already we have seen the effect of ionic bonding. So carbon and nitrogen generally tend to form covalent compounds because nitrogen has half-filled configuration 2s2 2p3. Half-filled configuration is completely stable. Completely stable means you cannot add a electron or remove electron so easily. So, but for inert gas configuration it requires electrons. So that is achieved only by sharing. That is why nitrogen compounds are covalent. Similarly is the case with the carbon. Carbon is placed at the center in between two inert gases. One gas is helium. Its atomic number is 2, and another inert gas, the successive inert gas is neon. Its atomic number is 10. So 6 carbon is exactly placed at the center between two inert gases. For that, in order to achieve any inert gas configuration, it has to either lose 4 electrons, or it has to gain 4 electrons. Even in the terms definition we have studied up to third ionization energy, and second electron gain enthalpy is positive we have seen. So first electron gain enthalpy, energy is released in the first electron addition, but energy is required for the second electron addition. Energy requirement is very high for third electron addition. It is enormous for fourth electron addition. It is not at all possible. Similarly is the case with the ionization energy. So up to third ionization energy, aluminum, it is possible. Boron, aluminum, gallium, indium, thallium. But fourth ionization is not possible. That is why carbon and nitrogen compounds are covalent in nature. And also the ionization energy and electron affinity, they are quite related to the ionic compound formation as we have studied in the chemical bonding chapter. They have good relevance to the ionic bond. That is why the systems, first group elements and second group elements, halogens, oxides, they vary from ionic to covalent nature depending upon the implication of Fajon's rule: size of the anion, size of the cation, relative charges on anion, how the system varies from covalency to electrovalency, or even HCl is explained in terms of all these we have studied. Hydrogen chloride is partially covalent, partially ionic. Covalent character predominates in gas phase, ionic character predominates in aqueous phase. This we have studied. Now, valency is the combining capacity. Electronegativity, higher electronegativity means better compound formation capacity. So, fluorine is most electronegative, means that fluorine is highly reactive. So, reactivity is directly related to electronegativity. Reactivity is directly related to electronegativity. Fluorine is the most electronegative, means that fluorine is most reactive. Inert gases are not electronegative, inert gases are not reactive. Other compounds are less electronegative, they are less reactive. That is why fluorine is separately dealt. Even in the compounds, halogenation we will refer to either chlorination or bromination or iodination. Chlorination is separately dealt. Fluorine reactivity is quite high. You will compare in terms. Normal chlorination takes place in the presence of light. Bromination takes place in the presence of light and heat. Iodination takes place in the presence of light, heat and catalyst. But fluorination takes place in the absence of any three. We got to be careful about that. The reaction is not taking place. That is, negative catalysts are introduced so as to avoid fluorination. Fluorination has to be carefully done. So fluorine is highly electronegative, means that it is highly reactive. So reactivity is directly related to electronegativity. That is one. Second one, metallic character. Electronegativity is inversely related to metallic character. If this element is more electronegative, that will be less metallic. Oxygen is more electronegative, so oxygen is not metal. And left first group elements, lithium, sodium, potassium, beryllium, magnesium, these are electropositive. They are not electronegative. So electronegativity is least for first group and second group. So they have high metallic content. Highly metallic content. Even in the case nitrogen, phosphorus, arsenic, antimony, bismuth, we have seen about. So here bismuth can form its 2 plus. Bismuth, it can lose 2 electrons to form bismuth 2 plus. So Sb2 plus and As2 plus hardly form. That is why bismuth, since it forms ions easily, so it becomes better as a metal. So 2 plus means electropositive. Electropositive means electronegativity character is low. Low electronegativity means more metallic. So bismuth is highly metal. Here they will form with difficulty, they will form the 2 plus, As2 plus, As3 plus, etc. But that is why they are called metalloids. But nitrogen will not form its ions at all. N plus is not stable, N plus will not form. Then only the question of stability. N plus will not form, N minus will not form. So it will not easily. So, but it has good, very good. Although the compounds, even in the covalent compounds, nitrogen is bonded, bond order is very high. If you take the compound, nitrogen, bond order is 3. Cyanide, bond order is 3. So, nitric oxide, nitrogen oxide, any, in no, very rare systems only, it shows a single bond order, CH3, NH2. In this only, it forms bond order is 1. So, mostly bond order is high. Bond order is high means both the electrons are better bonded. Better bonded means we cannot remove one electron or add one electron. It is not at all possible. So, that is to be noted. Electronegativity is inversely related to the metallic character of the element. Third property which is influenced by electronegativity, the nature of oxides. Nature of oxides. So the same we will compare. Boron, carbon, nitrogen, oxygen, fluorine, neon, like that. So let us from left, hydrogen, lithium, like this, beryllium, sodium, potassium. So from left to right, lithium oxide formula is Li2O, similar to hydrogen oxide. Water is H2O, its group element lithium oxide Li2O. Beryllium oxide, beryllium magnesium BeO, beryllium, magnesium, calcium, etc. That formula is BeO, lithium oxide, beryllium oxide. So here valency is 2. So we are comparing the valency as well as reactivity for oxides. What is the nature of oxides? So lithium oxide, first let us write the one period elements and then let us compare their oxides. Lithium oxide is Li2O. Beryllium, magnesium, boron, this BeO. Boron oxide B2O3. Carbon oxide, 2 types of oxides, carbon dioxide, carbon monoxide, and also carbonate is also stable, carbonic acid. Bicarbonate is stable, sodium bicarbonate. Different types of compounds it forms. All these are next nitrogen oxides, variety of nitrogen oxides. N2O, NO, NO2, NO3 minus, N2O4, N2O5. Even in organic compounds, this NO plus is there, and NO2 plus is there. NO2 minus is also there. Variety of compounds with respect to, but none of them is spontaneous. That is the thing. So many compounds are written with respect to nitrogen and oxygen, but none of them is spontaneous. If one of them is spontaneous, we cannot respire air nitrogen. Air contains a mixture of nitrogen and oxygen. Nitrogen without causing any disturbance goes into our metabolic system, comes out of the system. But the same is not possible with mercury. Mercury also has no easily reaction, but mercury poisoning, we tell. So mercury gets accumulated into the central nervous system, collapses the nervous system, paralytic attacks, etc. so forth take place. But nitrogen, so even this nitrogen also in some cases will be critical. That is why during hospital admission respiration they put masks for oxygen carrying only, respiration purpose oxygen masks are given. What is the purpose of oxygen mask? This nitrogen also may play under these conditions. So under these may play a suspicion, that is to be noted. So lithium oxide, beryllium oxide, boron oxide, nitrogen variety of oxides and carbon oxide, fluorine oxide is limited. Yeah, OF2 it is called, only one compound, OF2. And neon, no oxide, neon oxide, but xenon is there, XeOF2, it is not forming oxide, XeOF2, oxyfluoride, xenon, oxyfluoride. Boron group elements, boron, aluminium, gallium, indium, thallium. Boron oxide is B2O3, aluminium oxide Al2O3, we are aware. Nitrogen oxides, nitrogen, phosphorus oxide P2O3, P2O5, sulfur oxides SO2, SO3, variety of oxides are there. But from left to right, acidity increases. Acidity increases. Right to left, alkalinity increases. Acidity and alkalinity are opposite terms, two another. So acidity increases means that highly alkaline, less alkaline, amphoteric or neutral. Amphoteric means, so amphoteric and neutral, acidic oxides. We will see once again, recall the concepts of different types of oxides. Oxides are of four types: acidic oxides, basic oxides, neutral oxides and amphoteric oxides. Acidic oxides are the ones which when dissolved in water reduce the pH. Acidic oxides. Nitric oxide, nitric acid. Sulfur oxide, sulfuric acid. Chlorine oxide, chloric acid, perchloric acid, like that. Whereas sodium oxide when dissolved in water, sodium hydroxide. Sodium oxide on dissolution in water, sodium hydroxide. Aluminium oxide, aluminium hydroxide. Zinc oxide, zinc hydroxide. So amphoteric is one. So two types of oxides. Amphoteric which can react with acids as well as bases. Here we have to be careful about only two types, acidic and basic. The other combination should be only neutral. Fourth combination is also there. Acidic means pH less than 7. Basic means pH more than 7. Neutral means pH is around 7. Neither acidic nor basic. But amphoteric means both acidic and basic. Means that depending upon the environment, it will behave as acidic compound as well as basic compound. So from the left to right, acidic character increases. That is why right side sulfur, nitrogen, etc. occurs. Their oxides, nitric acid, sulfuric acid, hydrofluoric acid or fluorosilicates, this. But left, sodium oxide, lithium oxide, magnesium oxide, these they form basic, or hydroxides are more basic, Here, boron, aluminium, zinc, their oxides are amphoteric in nature. Silicon dioxide is the standard example for amphoteric oxide. It can react with acids and bases. So, the nature of oxides of any metal depends upon the electronegativity. Fluorine is highly electronegativity. Fluorine halogens are highly electronegative. Their oxyacids, their compounds itself called oxyacids. Acids, oxyacids. What is meant by HCl formula? Hydrochloric acid. HOCl, hypochlorous acid. HCl O3, perchloric, all are acids. Perchloric acid. HCl O4, say this one chloric acid. So you have to be careful about the spelling. This one perchloric acid. This is hypochlorous acid. Hypochlorous acid. This one hydrochloric acid. All are acids. So all contain hydrogen and chlorine as well as oxygen. Last three are called oxyacids. They contain oxygen as well as acidic in nature. Oxyacids. So from this very good oxyacids are formed. Variety of acids. Nitrogen, nitrous acid, HNO2. Nitric oxide, HNO3. Sulfurous acid, H2SO3, H2SO4, H2SO5. Even. That is to be even H2S2O8, peroxy disulfuric acid. Variety of acids. But carbon acids are weaker than this because carbon is in the middle. Carbonic acid, acetic acid, organic acid, acetic acid, oxalic acid, they form acetic acid formula CH3 COOH. Oxalic acid COOH COOH. Like that. So these are acids. So in general, acidic behavior of oxides or oxyacids increases from left to right because in electronegativity increases from left to right. Valency or combining capacity is improved from left to right up to halogens. But lastly, it is inert gas. Inert gas. So everywhere inert gas has no role. So any periodic property carefully to be compared only up to halogens. Only up to halogens. That is to be noted. So these are some of the variations. In individual examples, we will see why particular element is more electronegative or less electronegative, or what is the behavior that can be illustrated with questions.